Hi, so here is my demonstration video of the doubly linked list. So first of all, we can see this on this all code was given, and here is a class named as doubly linked list. And in this class, first of all, we have a nested class that is node that is inheriting from the inode. Uh, this one that the interface. So we can see in this in nested class we have a value we for the node, and there's a next pointer and the previous pointer, and in this we can see the constructor of this nested class in which we initialize the value, the previous and the next pointers, and it's a overridable toString method which converts the list into the string for printing. So that's all for the nested class. Now coming to the back to the outer class, we got a head and a tail, and the count, the amount of list, the total numbers in the list present, and here's the constructor of the doubly linked list, the outer class, in which we have initialized the head, tail, and we have set it the head dot next is equals to tail. So all of it was given already. Yeah, this method just return the first element in the list. This method return the last element in the list, and this method adds the node after the node given in the parameter. So what it basically does is, if the node came in the parameter is null, it throws a null reference exception, and otherwise it's if it's all good, then it will add the node after the given node. Then we have a method add last, which just add the given value as a node at the end of the list. Then the next one is add between, in which we can see a value and a previous node and the next node is coming as parameters. So basically what this does is just add a new node containing this value uh, between this previous node and the next node. And this is just a finding method if we need to check if this value is in this list or not. And same as this is a toString overridable method for printing out the list. So here we go. These are the methods that we have implemented. First of all, this is before, named as before. It just returns the node which is present before this node coming in parameter. So what we have done is, if we firstly check that if the node came in parameter is null or not. If it is, then we just throw a null reference exception. Otherwise we do some lines. Here you can see I just created a current node uh, for the node that just came, just to make sure. And for this current node that just came from the parameter, we check if its previous is null or its next is null. If it is both are null, that means this node is no longer present in the list, so it will throw an invalid operation exception. And if the node current dot next the next node after this node equals to tail, then we return null. Otherwise we return the previous node of the coming node from the parameter. So here we have an add first method in which we add a node containing this value in the list. we just simply return a statement that is add between. That's the function already given, which add between two nodes a value. So here's the value that came from the parameter, and add, we have to add the first. So the previous of the add between will be the head, and the next will be the head dot next, and the value will be placed between this. So automatically it will be the first value in the list. After that, we can see we have an add before method. So what it does is it add a node, this value containing this value before this node. So you can see, first of all we check if the node came is not null. If it's null, then we will go through an argument null exception. Otherwise we will do the same. We will create a new node as node current, uh, that is the before node that came in the parameter to perform some actions. And here you can see we have done the same thing again. If the previous and the next pointers of this node are null, that means it's not present, so the node referred at because it's no longer in the list. That's we will control an invalid operation exception with that message. Otherwise we will check if the current node is the head value, like just because the head is the pointer. So if that's the first value of the list, so we're gonna make the add between statement for the value head and head next. That's previous, and that's next. That means we're gonna add the new node, the new value in the first place of the list. Else we will do the same with the add between. We will, this is the value to be given. The previous node will be the node current, the node given before we have to put that value, so that is the previous, and that's the node current, the current node, which will be the after node of the new node. After that, there is an add after method in which we're gonna add after this node a node of this value. So first of all we will check if it's not null. If it's null, then we're gonna throw argument null exception. So same thing, node current is equals to after as node, we create a new node for the node that came to perform actions. For then we will check again the previous and the next pointers. If it's null, then we're gonna throw the invalid operation exception. Otherwise we're gonna again return add between value node current dot next dot previous, that's, and the net node current dot next, because we're gonna add after this one, after this. So here's the clear method in which we're gonna clear the whole list. So you can see we have created a node from the tail dot previous. So we're gonna start the clearing method from the tail. So we will loop until the node becomes the head, and all the nodes came in between dot next will be nullified, and that's just to uh, move back to the previous node. Then we will set the head and tail as new nodes, that the for null null, and the tail previous is obviously head, and then head dot next is equals to tail, and the counter will be sent to 0. Then we got a remove method. That's if we're gonna remove this node that came in the parameter. So if the node is null, then we're gonna throw argument null exception. The same thing again, node current is equals to node, that making a new node for the performing the actions, and then we just check if it's not null the both next and previous. If it is, then the invalid operation exception, and then we're gonna check if the node to be removed is the head node, that is head dot next. So if it will be the head node, then it will be easy to remove it, because we will just set the pointer, that is head dot next is equals to node current dot next. So the value to be removed to the next value of the value to be removed will become the head, and then with node current that is to be removed will be nullified, and counter will be decremented. Else we will check if it is a tail, like the value to be removed is the tail. So we will just make the tail the value before the value to be removed, that is node current dot previous, and then again node current is null and counter will be decremented. Else if it's not both head and tail, then we're gonna do some actions, that is we have created a temp node in which we will store the previous node of the node to be removed, that is node current dot previous, and then we will node current dot previous dot next is equals to node current dot next, and the node current dot next dot previous will be the temp which we just stored, and the node to be removed and the pointers over the both pointers, that is previous next, will be nullified and the counter will be decremented. So that's how we will remove, and it's again same as the we have done here. If that's the value to be removed is head value, the same thing we have done in the remove first, and the first value is always head value, and in the remove last, same thing we have done here, because this is the same code for removing the last, that is tail. So this is the remove last method, and this is all. I'm just gonna run it for you to check if it's all working good. See, A, B, C, D, E, F, G, H, I, K, all tests are passed. So our Doubly linked list is working well. Thank you.